What are the routine electrical tests in industrial systems? Regular testing is crucial for ensuring the safety, reliability, and longevity of industrial electrical systems. These tests help identify potential problems before they lead to failures, downtime, or safety hazards. This document provides a comprehensive overview of common electrical tests performed in industrial settings, detailing their purposes, methodologies, and recommended frequencies. 1. Insulation resistance testing, Megger testing. Purpose: measures the resistance between conductors and ground, assessing the quality of insulation. Degraded insulation can lead to leakage currents and potential short circuits. How it works: a high DC voltage is applied, and the resulting current is measured. A low resistance reading indicates poor insulation. Frequency: regularly scheduled, based on equipment type and environment. Standards: follow relevant standards, e.g., IEC, IEEE. 2. Winding resistance testing. Purpose: measures the resistance of transformer or motor windings. Helps detect shorted turns, loose connections, or other winding damage. How it works: a DC current is passed through the winding, and the voltage drop is measured. Frequency: regularly scheduled, especially for transformers and large motors. 3. Continuity testing. Purpose: verifies the integrity of a circuit path. Ensures that connections are properly made and there are no breaks in the circuit. How it works: a low voltage is applied, and a meter checks for current flow. Frequency: as needed, especially during installation or troubleshooting. 4. High voltage testing, dielectric withstand test. Purpose: tests the insulation strength of equipment by applying a high voltage. Ensures the insulation can withstand overvoltage conditions. How it works: a high AC or DC voltage is applied for a specified time. Frequency: typically performed during commissioning and periodically thereafter. Caution: this test should only be performed by highly trained personnel. 5. Visual inspection. Purpose: a thorough visual check of all electrical components for signs of damage, wear, loose connections, overheating, or other abnormalities. How it works: physical inspection of equipment, including wiring, connections, enclosures, and other components. Frequency: regularly, ideally during routine maintenance. 6. Polarity testing. Purpose: confirms the correct phase sequence of conductors. Essential for proper operation of three-phase systems and preventing equipment damage. How it works: various methods, including phase rotation testers. Frequency: during installation and after any modifications to the wiring. 7. Earth fault loop impedance testing. Purpose: measures the impedance of the earth fault loop, which is the path for fault current to return to the source. Ensures that protective devices, e.g., circuit breakers, will operate quickly in the event of a fault. How it works: specialized testers measure the impedance. Frequency: regularly scheduled. 8. Contact resistance testing. Purpose: measures the resistance of electrical contacts, such as those in circuit breakers or switches. High resistance can lead to overheating and premature failure. How it works: a low current is passed through the contacts, and the voltage drop is measured. Frequency: regularly, especially for circuit breakers. 9. Voltage ratio measurement, transformer turns ratio test. Purpose: verifies the turns ratio of a transformer, ensuring that it is providing the correct voltage transformation. How it works: voltage is applied to one winding, and the voltage across the other winding is measured. frequency, during commissioning and periodically. 10 other tests, depending on the specific equipment. Mechanical operation tests, for circuit breakers and other switching devices, to verify proper mechanical operation. Timing and velocity measurements, for circuit breakers, to assess operating speed. Leakage tests, for gas-insulated equipment, e.g., SF6 circuit breakers. Protective relay testing, to ensure that protective relays are operating correctly. Key considerations for all tests. Frequency, establish a regular testing schedule based on equipment type, operating conditions, and manufacturer recommendations. Standards, adhere to relevant electrical safety standards, e.g., IEC, IEEE, national standards. Qualified personnel, all testing should be performed by trained and qualified personnel. Documentation, maintain detailed records of all test results.